Welcome to Chapter 5, Paragraph 2, Driving Forces and Resisting Forces. This lesson will be about driving forces and resisting forces, the resultant changes the speed, and there will be an example on how to do the questions. Let's start with driving forces and resisting forces. When you are riding on your bicycle, there's one driving force acting on you when you are pedaling your bicycle. But there are several resisting forces acting on you and the bicycle. For instance, you have the resistance due to air friction. You can notice this when you make yourself bigger or smaller on the bicycle, or when you put your hands out. Then there is also the resistance due to rolling friction. You can notice this when you have your best friend on the back of the bicycle. But how can we make it easy for us to know what force there is on an object? This brings us to the resultant force. What is the resultant force? When we look at a stationary object like you and your bicycle, or in this example a pushcart, we notice a few forces on them. We notice the force of gravity, we notice the normal force, we notice a force of friction and the force of pushing. When the object is not accelerating, this means that all forces balance each other out. We then say that the resultant force is zero. The resultant force means that all forces are combined to one force acting on the object. So, what happens when the resultant has a certain value? When the resultant force is zero, the velocity will not change. If the object already has a velocity, it will not go quicker or slower. You will continue to have the same speed. But what will happen when the resultant does not equal zero? The object will then start to accelerate in the direction that it is pointing. When the resultant is positive, the car or the object will start to accelerate. When the resultant is negative, the car will slow down. Let's have a look at this picture of a car. We can see there are four forces acting on the car. To make this example more easy, we have made it seem that all forces act on the center of gravity. We can see the force of gravity pointing down, the normal force is pointing up, the resisting forces are pointing left, and the pushing forces are pointing right. The force of gravity and the normal force are equal in size, but they have different directions. They balance each other out. The pushing force, however, is much larger than the resisting force. This means that the resultant force, F resultant, is positive to the right. The car will accelerate. Let's look at picture number 2. Picture number 2 shows the exact same car. The force of gravity and the normal force are still present, but we did not draw them. This time there is no pushing force, but there is a large resistance force. This means that the resultant force is positive to the left. The car will decelerate and slow down. Let's do an example question together. Question 18 from your textbook, page 189. First, try to do it yourself, and then come back to me and see if you do the same steps and come to the same answer. Let's have a look at the information in the question. Carla is riding on her racing bike. The diagram shows us how large the resisting force is at what speed. Can you see that the graph gives this information? Okay, question A. Carla starts by cycling for a while at a steady speed of 11 meters a second. How big is the driving force then? The information in the question is that Carla is cycling at a constant speed of 11 meters a second. What does the constant speed tells us? The constant speed tells us that Carla is not accelerating or decelerating. This means that the resultant force must be zero. When the resultant force is zero, this means that the resisting force must be equal in size of the driving force. F resisting equals F driving. We can now use the diagram to read out the resisting forces at the speed of 11 meters a second. We can see that at a speed of 11 meters a second, the resisting forces are 30 newtons. I have made this clear using the green dotted line in the diagram. Question B. At a certain point, Carla starts pushing harder on the pedals. This means that the driving force of 40 newton is applied to her bicycle for a while. What is the resultant at the moment when she starts to accelerate? So, Carla is cycling at 11 meters a second and then starts pushing harder on her pedals. Her force now reaches 40 newton. What is the resultant at this moment? The resultant force can be found by adding all forces in the same direction together. The resistance force is directly opposite of the driving force. We can calculate the resultant force by deducting the resisting force off from the driving force. F resulting is F driving minus F resisting. Or in other words, F resulting is 40 newtons minus 30 newtons. This equals to 10 newtons. Can everybody see this? Okay, good. Final question. Determine the final speed that Carla achieves. To tackle this problem, think of what is asked. The question asks for the final speed if Carla has a driving force of 40 newtons. The final speed is the speed where Carla would not accelerate anymore. When she is not accelerating no more, the resultant force would need to be 0 newtons, cause at the resultant force of 0 newton there is no acceleration or deceleration. This means that the resisting force needs to be equal to the driving force, as F resultant is F driving minus F resisting. The questions ask us to determine this, which means we are allowed to read it in the diagram. So, at what force would there be no acceleration? Correctly, this would be when the resisting force is equal to the driving force of 40 newtons. Looking in the diagram, we can see that at the resisting force of 40 newtons, the speed would be 12.8 meters a second, as shown by the orange dotted line. What did we learn this lesson? We now know what driving forces are and what resisting forces are. We know what the resultant is, we know how to calculate the resultant, and we know what the resultant does to the speed. The homework for next lesson is look at paragraph 1 and 2. What subject still needs more explaining, or what do you find difficult to do? Write this down, including the 3 answers of question 18, on a small piece of paper and give it to the teacher when you come into the classroom to let him know that you saw this video.